right, so we are going to continue with our summary for lesson 5.5, talking about properties of parallelograms. So the conjectures we discovered in our investigation were parallelogram opposite angles conjecture. The opposite angles of a parallelogram are congruent. Parallelogram consecutive angles conjecture. The consecutive angles of a parallelogram are supplementary. Parallelogram opposite sides conjecture. The opposite sides of a parallelogram are congruent. And then the parallelogram diagonals conjecture. The diagonals of a parallelogram bisect each other. I think for most of us, we knew the first three conjectures from middle school, but maybe the diagonals conjecture was something new for us. Let's take a look at how we're going to apply these. So hopefully you recognize some of these questions from your homework assignments. All right. So the first question on the left-hand side wishes us to find the value of E and F. So taking a look here, see what color pen I have assigned. I'm going to go with something lovely, bright, like the green. Okay, F is pretty easy to find because it's diagonal from 78 degrees. So the measure of that would be 78 degrees. Ignore my updates. All right, and now we want to find E. So E is kind of sort of opposite. It is an alternate interior angle to the 63 degrees. It's a parallelogram. We know that this is going to be parallel to that. So that means this is a transversal. So our alternating interior angles means angle E is 63 degrees. You could have also figured it out by figuring out what is the total measure of this angle by subtracting it from 180, and then solving for that tiny part, and then going from there. But actually, no, that would have been more complicated. You still would have had to use alternate interior angles. So the first way was easiest. The second example, we want to find G and H. All right? Well, opposite sides of a parallelogram are congruent, so if this is 16 inches, then that means G is also 16 inches. And then the diagonals. The diagonals of the parallelogram bisect each other. So if MO is 14 inches, that means H is also 14 inches. So nice and easy when we know these basic conjectures, we can solve the pretty simple problems. Let's take a look at what happens when we have maybe slightly more complicated problems. Oh goodness. Nice, lovely, bright green line. Let's delete that. And go to our mouse. Taking a look at the next slide. Let's take a look at a proof that we want to develop. And we are given that LEAN is a parallelogram, and so you can see from the picture near the right-hand side. And we want to prove or show that line segment EN and LA bisect each other. A couple of different ways you can set this up. Use a paragraph proof, use a flowchart proof, use a two-column proof, whatever you want to do. I'm old school, so I like to use the two-column proofs. I'm going to go actually out quite a bit further because I want to have some space to write here. So, the information, and then what proof are we showing? Like why? So we're told that LAN is a parallelogram. So the first thing we can say is that EA, line segment EA, line segment EA is congruent to line segment LN because of the parallelogram opposite sides conjecture. I'm going to abbreviate that to para opposite sides conjecture. Okay. Second, oh, that is really annoying. I should figure out why he keeps doing that. All right, so second, we know that angle AEN is congruent to angle LNE because of the alternate interior angles conjecture. So alternate interior angles conjecture. Since the sides are parallel. That's this angle over here, AEN. This angle here And then L and E is this angle here. Part 3, angle ETA is congruent to angle NLT. So ETA here and NLT. Oops, I think I named that one incorrectly. ETA, so NTL. NTL. Alright, and those are congruent because of vertical angles. So the vertical angle conjecture. So now we know that triangle EAT is congruent to triangle EAT, so NLT, because of angle side conjecture. So using one of our triangle sum conjectures. Adams, part 4. All right. So now, I had to clear off that. So if you need to pause to copy that down, I'm going to erase it so I can have some more space. So we've already proven the first 4 steps. Now let's continue on. Step 5, LT, line segment LT is congruent to line segment AT, and line segment ET is congruent to line segment NT, and that's because of CP, CTC. Corresponding parts of congruent triangles are congruent. So now that we have proven that LT is congruent to AT, and ET is congruent to TN or NT, we can say that LA bisects EN, and EN bisects LA. So we have proven that the conjecture, the parallelogram diagonals conjecture, we have proven it to be true. Notice I didn't start off with that at the very beginning because part of the example was to prove that these conjectures were true. So we showed them in the investigation, but let's prove it with some of our deductive reasoning from geometry. The investigations are inductive, the proofs are more deductive. Alright, and that's it for lesson 5.5. If you have any questions, make sure to ask me in class or email or however you normally would.